Hello everybody, welcome to the end of November rocket launch. This is just a short launch where we designed and printed a bunch of new parts for rockets, just experimenting with better ways to print them and better ways to make the parts that we use to assemble the rockets. And so what I've got today is a bunch of rockets that are really just a combination of those leftover parts. We did try to make them look pretty good, and here is an example of what we've done. Most of them are a bit small. As you can see, usual suspects, a little shadowy. Cool. And we've got one on the launch pad right now, very small. All right, what do we got there, Casp?
This is a B. I don't know if it's named.
Just a B.
It's supposed to go 150 miles per hour and reach 481 feet in the air. And what is this measurement right here? Cal.
Oh yeah. Thanks for bringing that up, Cap. So essentially, we've added a new measurement. So what we've done is added the measurement of stability. So for a rocket to be stable, the center of pressure must be behind the center of gravity. And generally, that ratio should be the diameter of the rocket. So if you have a 1-inch diameter rocket, the center of gravity should be 1 inch or more in front of the center of pressure. The center of pressure is the total of all the forces that are acting on the rocket, including crosswinds, lift, all the jazz. Acceleration,
and drag,
gravity, the rig. So anyway, we've done this calculation so we can see how well our calculations predict what happens to the rocket. So this rocket here is a 2.65 coefficient of stability. And so we imagine it would be very stable. So let's find out.
So 3, 2, 1. 3, 2, 1.
Fudge.
3, 2, 1. What? 3, 2, 1.
Yay.
There we go.
Ew.
3, 2, 1. Oh
My fuck. We think we have some bad luck with bees, which seems to be something that happens. These are Estes bees, but we're going to put a C in, which is going to change the behavior of this rocket quite a lot. Let's just see what happens. You're ready.
3, 2, 1.
Wow, that really went fast, and it went really high, and it deployed.
That is a good question.
I see
something up there.
Yeah, I don't know what's.
I can't tell if it's streamer or rocket.
I think it broke into pieces.
Well, no, I think it's the
Oh, there it is.
streamer.
Boom.
I don't think the streamer came out.
I don't think a streamer came out. All right, well. Okay, so this is a duplicate rocket to the rocket that we just launched. This one has no cone deployment. It has a B in. We've had some bad luck with these bees, and we suspect we'll have bad luck with this bee too. But now we know we can just put a C in if we need to. Sure they're not touching. All good?
Yep. 3, 2, 1.
Good work. Nice. And it deployed. And it is falling. So it didn't, well,
It was a much less climactic.
much less climactic, but at least it worked. This one is called B, because we didn't name any of these because they're just experiments. Has a C rocket in. We expect it to be stable. It's got a 2.0 coefficient of stability. 1 is the minimum stable. All right, ready?
Yep.
Here we go.
3, 2, 1. Well,
It was stable,
yeah.
and it has deployed very nicely. But do you see the recovery?
No, I think I haven't seen the.
Is there a
parachute
chute
right
or a
Or
streamer?
the streamer. I haven't seen that. Right?
All right, they're not, well, it's falling nice and slow. I'll tell you, it's down, right?
I have no idea.
I take your eye off it for a second, and
Yeah, the sun is pretty.
but that one is recoverable. It's just over there by the tree line. All right, we'll go check it out. So this rocket is another C rocket. It has a 2.0 coefficient of stability. So far that has been the magic number.
Yep.
So we'll see how this one goes. It has a C. We expect it'll go about 800 feet and achieve 175 miles an hour.
Okay.
Are you ready to go?
Yeah.
All right, here we go. Walking back. All right.
3, 2, 1.
Really nice, stable,
And deployment perfect.
and even went in the right direction.
Yep.
Oh my God, the parachutes come out.
It's perfect deployment.
Is that a parachute?
I don't know.
I think it is.
If I was feeling more lively today, I would run and catch it. Well, unless it comes right towards me. Nope, there it's gone.
Here it comes.
There it goes. That is, I can't tell. I'm blinded by the. Well, I guess we should go.
Let's go see. It's 2 feet away.
It really is.
Huh.
That looks rather shiny. Did you use proprietary parachutes?
It's a Mylar parachute.
Really?
I'll be damned.
Looks like a streamer to me. Unless no, it's,
Oh.
it is a pair. It's 2 parachutes.
Is it 2 parachutes or did the
Or
parachute
one
rip?
that ripped. Yeah.
Oh, the parachute rip. But, you know, what are you going to do? Okay, so this rocket is called A. Again, it's, you know, I did a lot of improving of how parts are constructed. And this one is very thin. It should go 640 feet, 151 miles an hour. I did not record the stability quotient, but I imagine since it's so
I think
thin.
it's right here, actually.
Oh, what's it saying?
I don't know. 3 something maybe?
Oh, 3.
3.26,
Yeah,
I would
3
guess.
is massively overstable. Someday we'll talk about the difference between overstable and stable, but not today. All right, here we go.
3, 2, 1.
Very stable.
Very stable. Yeah, once they get going, they're really stable.
Oh,
Oh, it broke into pieces.
It did, and there goes the
Parachute slash streamer is off. And the rocket itself, though, seems like it's kind of not slow.
it does cap. It fell, something came off it.
It's falling DOD. Yeah, something, a 2-part system came off of it. So.
All right, it's gonna recover close by.
Yep. That looks like you can see right where the parachute ripped off. Cause
Yeah,
it's
the
short,
parachute ripped
shiny,
off, but otherwise it
and look,
worked.
It's still up reflecting in the sky up there. You probably
Oh,
can't get it
yeah,
on
I can
camera,
see it.
Yep.
You probably can't see it in the camera.
But I bet that's the, maybe that's the
That's the
engine
parachute.
compartment and parachute or something.
Yeah.
Or whatever it was attached to.
All right, well, that's cool. That's going a long way
Yeah,
off.
it might be in the pit.
Yeah. All right, so this is got a D rocket in it. It's exactly a duplicate of a earlier rocket which had a C rocket. It's at that tapered look. This one is 1.9 coefficient of stability, so still more than enough, but slightly less stable with the bigger D engine. All right, let's see what the consequences of increasing that engine size are.
3, 2, 1.
Wow!
I wonder if that was a gust. If so, it was very stable.
Really high.
It looks like it's just tumbling.
It's coming down pretty slow, or it's just very far away.
Yeah, it looks like it's just tumbling through the air.
Yeah. It's just tumbling away.
But it's not reaching.
Oh, I think it's in the pit, Cap.
Destined for the pit. Oh well. It's interesting how it's reaching some stability flat.
Oh, it's just on the edge of the pit. We might be able to get it. This is another D motor, another unnamed rocket. This one should go 900 feet. It's got a 2.6 coefficient of stability. And let's just see how it goes. All right. Ready, KP.
3, 2, 1.
Wow. Really? Oh,
And
good.
Perfect deployment.
It's going right over my head. Keep it in my eyeballs. It's right over my head. There it is. There is some deployment-y stuff happening.
Yeah, it seems like
It's just tangled.
yeah,
Oh, it's getting away from us.
it's just drifting. No, I don't know, it might not be destined for the pit yet.
There's definitely a parachute trying to operate.
Yeah. But maybe that one needed 2 parachutes. Well,
Oh, we're gonna
There
get
it
it. All right, so here's an example of a new design for the rail gripper, which holds the rocket to the launch rail until it gets up there. We'll have lots more of those next launch. This was the prototype.
yes.
And this rocket has a D7 rocket, which is a 24 millimeter D. Should go 975. It has a stability of only
1.6.
1.6, so that's getting closer to marginal.
But it may be that being perfectly stable is better than overstable. So.
But we'll find out. And we'll hope that everything that's attached to it stays attached to it till it gets in the sky. All right.
This is what? This is a D plus.
D plus, yeah, so a 24 millimeter D.
All right.
All right, here we go.
3, 2, 1.
Really stable.
And
Oh, it's ballistic. That is ballistic, all right.
Yep.
All right, Casper's now loading the last rocket of the day. This has an E motor in it. Careful, careful, don't force it. There you go. It has an E motor in it. It has no name, it's just parts we had laying around that I put together. I don't even know how stable it is, but I guess it's about 1.5. And we'll find out in a minute. It should go really, really high because it is on the small size for an E motor. So let's see what happens.
3, 2, 1.
Oh, wow.
Stable.
Really stable. It's right over my head. Really high. Oh, right. It deployed.
Oh, I think it's broken up actually. Oh, part of it's ballistic.
Okay. Part of it's ballistic, part of it is coming.
Actually. And shattered into pieces, and then there's probably parachuting those guys.
Yeah, I've got the last piece still coming down slow. The ballistic piece we heard hit and
Yep,
break up. I think that's gonna go to the pit though, Cap.
Alright.
Well, I didn't think we'd get it back.
You were right.
I gotta do something about it, them falling apart. I think my...
You might need stronger linkages. Yeah, that is destined for the pit.
That's the pit. You know what I think it is? I think my shot cords aren't long enough.
Interesting. So
Yeah.
they don't have enough